Hey there. So this section is about a billion times easier than the previous section if you just wrapped up negative exponents. In this one, we're working with, it's our first section on polynomials, which will finish out this chapter, um, just working through operations polynomials. And in this one, we're going to look at two things. We're going to look at evaluating them, which we pretty much already have done, but we'll just refresh on that. And then adding and subtracting polynomials, especially when they have higher powers. We've actually been doing this like in the linear chapter, but we haven't seen it with higher powers of x. So first off, we'll just do one evaluate here, just to kind of remind you how this goes. And I picked one that has a negative value because it's pretty much the science that gets people on these. So if y equals this stuff, find y if x is -3. So that's just telling us to plug in -3 and simplify all this and see what the y comes out to. So, oops, I forgot to do this first. Cool. So we'd have y equals -2, oops, not x because we're evaluating. So right there we'd have a -3, and that will be squared. And then the 1 is kind of silly there. So I'll just write it plus -3 and then -9. So working this out, so right there you have a -3 squared, which is going to make a +9. That's going to be multiplied by a negative, which is going to flip it back to a negative. A nice way of looking at that is you got 1, 2, 3 negative signs, and so you know it's going to be a negative value. But if we follow our order of operations, -3 times -3 would make +9, but then times the -2 flips us back to a -18. Plus a -3, I'll just clean that up to write it as -3 and -9. And so that would be -18 minus another 12. So it looks like y should be -30, and then that would be it. For adding and subtracting polynomials, the thing to remember about this is that we can only add and subtract like terms. So for this, we can when we add and subtract, let's think about what we've done before. When we had 2x plus 5x, for instance, we left the x's alone. We just said we have 2 of these things and 5 of these things, and that made 7 of those things. So when we're adding and subtracting, we are combining based on the coefficients, but we can only combine like terms. So like for this one, the fourths have to go with the fourths, the thirds with the thirds, seconds with the seconds, and so on. Another thing where people get a little messed up is when they are multiplying versus adding. So x plus x, we'll do the simplest case because this is one that really gets people, is I have 1x plus another x, and that would be 2 x's. And notice nothing happened to that x. If you pretend for a second x was 5, 5 plus 5 should make 10. 2 times 5 does make 10. We just wrapped up multiplying like with powers. X times x, that one would be x squared. We'll see multiplication coming up in the next section, but careful not to confuse basically those two things is kind of where people get messed up. And this would have been 5 times 5 is 25, 5 squared, 25. So we're looking for things that have the same. X to the fourths will go together, x to the thirds are going to go together, x squareds are going to go together. That's one of the nice things about writing things in descending order. And then the constants are going to go together. So I have 10x to the fourth minus 10x to the fourth. Great, those are gone. For my cubes, I have -3x cubed minus another 12x. So it's really -3 plus -12, and that would be -15x cubed. For squareds, we'd have +8 plus another 12, so that would give us +20x squared. And then for constant terms, we have -10 plus 7, so we're down 10, coming back up 7, and that would leave us at -3 right there. Subtraction is just kind of one step harder. With the addition, the signs are just what they look like. It's this plus that. With the subtraction, we need to think of that little minus in there as an invisible -1 that's going to get distributed to everything in the parentheses. And when you're really comfortable with this, you certainly don't need to write this step out, but for now in the video, I'm going to rewrite this with just kind of distributing that sign through and showing my work. So that would be negative 8x to the fifth minus 7x squared minus 6x, and then that's going to basically just flip all the signs. I hate that the computer puts a 1 there, so I'm just going to write that as minus x to the fifth is a little bit more proper, minus 10x squared, and minus 6. And then we just think of it as, again, combining our like terms. So we have some x to the fifths that are going to go together, some x squareds that are going to go together, and then these two are not like, so we'll just write those out again. And with all this, if you notice, we're going descending order. One of the nice things about having stuff in descending order is it makes it easy to kind of match up your pieces and not miss things. So we got minus 8 and then minus the invisible 1, so that would make minus 9x to the fifths. For the x squareds, I have minus 7x squareds minus another 10x squared, so that's going to give us minus 17x squared. Negative or minus 6x, that's the only term involving x, so we'll minus 6x right there, and then minus 6 on the end, and that kept us in descending order. And this is basically kind of all there is to adding and subtracting. It's just being careful with the signs. 14, same basic thing. I'll go ahead and distribute that minus through again. So minus 10x cubed plus 6x squared plus 4x. Then that minus and minus is going to make that a plus 2x to the fourth. Minus is going to make that a plus x cubed, and another minus will make that a plus 11x. And then once you have that through, then your signs are all squared away and you're not having to kind of keep track of that in your head. So here our highest power is right there. It's that 2x to the fourth. So that's the one we want to lead with to get this in descending order. For our x cubed terms, I'm just going to kind of count down and find all the matching pieces. So I have minus 10 plus 1, so that's going to leave me minus 9x cubed. And then next we have x squareds, and that appears to be the only one. I already got that. So this one will go plus 6x squared, and then I have a plus 4x and a plus 11x, so those are also like terms, and that would give us 15x's altogether. Just double check and make sure I didn't mess anything up. Nope. And then this is the last example, same thing, just an extra piece. So again, I like to rewrite it without the parentheses. So 8x squared minus 6x minus 5. This is a plus, so those parentheses aren't actually doing anything, so we'll just rewrite this out. That one's a minus, so that one I do need to make sure that I get distributed through the parentheses. So that'll be a minus 7x cubed, flips that to a plus 9x squared. Minus would be plus 3. And so it looks like our highest power is cubes, so we got a cube there and a cube there. So 4 minus 7 would leave me minus 3x cubed. And then squareds, I got one here and right there. So 8x squared plus 9x squared, so that'll be plus 17x squareds. For linear terms, we got an x there, we got one there, that's it. So minus 6 minus 2 would be minus 8x. And then for our constants, it looks like we got right here, right there, and right there. So minus 5 plus 6 would be 1, plus another 3 should be plus 4. And I'll just double check that against my key and make sure I didn't lose any pieces. Nope, that looks good. So not too bad a section. It's just kind of keeping track of signs.